think shall we start the session?
Uh, Sir, you can start your session.
Okay. Okay, fine. So today, let's discuss about the second problem, that is developing a merge sort program using divide and conquer, and we'll also try to measure the running time. Actually, whenever we measure the running time,
Sir,
it is
sorry to
very
disturb you, sir.
okay.
Sir, actually, in a classroom, we connected in a projector, sir. So that's the
Okay.
reason the number of students are less, sir. We
Okay.
connected in a classroom. Please continue, sir, and thank you, sir.
Okay. That's fine. Uh, okay. So generally, when we use the running time of a sorting algorithm or any algorithm, it is very efficient or useful when we compare it with other sorting algorithms or something like that, right? So uh, generally, why we need sorting? Can I think if you can interact with me, that will be very good. Generally, where do we use sorting? Is sorting necessary? When we go to a movie theater, everything is sorted. Generally, in our lives, we feel everything should be sorted. So, and in the previous session, when we have learned about binary search, the primary condition is the list should be sorted. Then only we can use binary search on it. So you can say that as one of the uses. And when we come to merge sort is a merge sort also uses divide and conquer method. And when we have given a unsorted list, we divide it into simpler forms. If the length of the list is 10, we'll divide it uh, recursively until we get sublists of size 1 each. And then we compare with each other, compare it with other sublists, and we try to sort it. And generally, so if you know, I think you guys know about in place sortings or something like that. I'll explain you. If we create a new array, and if we see the least element in a list, and if we add in it, and after that if we again search the second least element and we add it in the new list, every time we are creating a new list and adding it, so this takes so much space, and the space complexity is also one that we should to keep in our mind, because we are not creating algorithms that will work on small sizes, but we want to create algorithms which will work on large data. So we have to keep that in mind. So whenever we create a program which does not require new list or new data storing data storing requirements, if we sort it in the given array itself, then we call it as in place algorithms. So merge sort is one of the algorithm where the where the sorting happens in place in the given array. They'll give us an array, so we'll sort it in the same array. We don't require a new array. And I want to show you a picture. 1 minute. That basically gives the idea of merge sort. Can you see my screen? So here the 6, 5, 12, 10, 9, 1 is the unsorted array. So every time we want to divide it first into equal halves until we get a single element, until there is only one element in the sublist. So 6, 5, 12 is one sublist, and 10, 9, 1 is another sublist. and after that 6 is one sublist, 5 12 is one sublist, because 3 divided by 2 is 1, and so it is divided into 1 and 2 equal parts. In the same way, 10 9 and 1, again we divide them into 6 5 12 10 9 1. Um, Now we compare each of them and sort it. So every time when after dividing them into sublist of length 1, every time when we have to merge them, the two lists that we are going to merge should be sorted. Will be sorted in merge sort algorithm. So in such a way, we have to write our code or our algorithm in such a way that the two sublists are always sorted. So here 6 is single element, so it will be 6 5 12. When we compare 5 with 12, 5 is less than 12, so it will be 5 12. 10 is a single element. When we compare 9 with 1, 1 is smaller than 9, so we'll have 1 and 9. So again, now we will compare 6 5 and 12. 5 is less than 6, so 5 comes here, and 12 is greater than 6, so it will be like this. So this is our logic and our algorithm. So we will try to uh, bring this a coding form or into an algorithm. One minute. Let's take an example first. First, let's try to solve it on paper, and then we'll try to bring it in the form of a code. And let's also try to see what's the time complexity of merge sort. I'll stop. I'll stop my. Can you see the small board, whiteboard? I think you can see it. I'll try to write in big letters. Let's see. I'll take an array, unsorted array. This is an unsorted array um, with 9 elements. So what's the length of the array is 9. The indexes are 0 to 8. So what will be the middle element? It's 9 by 9. The length of the array is 9. 9 by 2 is 4. So it will be here. I'll divide them into two halves. It will be 15, 5, 24, 8, 1 here, and 3, 16, 10, 20 here. I want to continue this process until I'll get the sublist of size 1. So every sublist should be of the size 1. So I'll continue this. Now the length of now this is our array. I'll again apply the dividing algorithm here. So the length of the array is 5 here. 5 by 2 is 2. So 15 and 5 will be here. Sorry, the indexes will be 0, 1, 2, 3, 4, right? I'm taking the indexes. So 15, 5 and 24 will be in one sublist. 8 and 1 will be in another sublist. Here it's even, so we'll have equal number of elements in both the sublists. That is 2, 10 and 20. Okay. Now again, if we continue the same process, in the end we'll have sublist which has single elements in it. But since we are using recursion here, whenever when we write the code, it will go to the next step only if the previous step is completed. So after I'll continue this process till I have the sublist which with length 1, and then I'll start to merge them. Can someone say what's the time complexity that will be happening when we are dividing the list? It is similar to our binary search. If you see, we are reducing it to equal halves every time, every iteration. So it will be log n. This is only for dividing. This is only for dividing. And then we'll compare 5 with 15. 5 is less than 15. So uh, now don't think about the code. Just manually compare them and try to sort it. 5 is less than 12. Um, I'm sorry, 1 minute. Since we are using recursion, it will be retraced in the it will backtrack in the same way how the recursion happened. So first it will be 5 and 15 here, and 24 will be like that itself, and 1 8 will be 1 will be compared with 8, and 1 is less than 8, so they will be sorted. Now 3 and 16 they're already sorted, so they will be like that only. And 10 and 20 are also already sorted, so they will be the same way. Now when we compare 24 with uh, 5 and 15, it is greater than 15. So we'll simply have 5, 15, and 24, and 1, 8 will be the same, and all the other elements will be same. And now we'll have, now we have 5, 15, 24, and 1, 8 in another sublist, and we have 3, 16 in one sublist, and we have 10, 20 in another sublist. So now we are trying to merge these two lists. Let's say 1 is less than 5, so it will be before 5, and 8 is greater than 5 and less than 15. So we'll have 8 here, 15, and 24. All the elements in the sublist are in the merged list. So the remaining elements in the list are directly added because this is already sorted. That is what I was talking about. We need not check the elements that are in the same list, because whenever we are merging them, it is it is granted that the list is already sorted and all the elements in it are uh, either ascending or descending. You can keep a condition for it. So then we'll add this. We'll merge these two. 10 is greater than 3 and less than 16. So we'll have it like this. So again we will do the same thing and we'll get the sorted list. So manually we can compare them like this, but do you have any idea how to turn this into a code? Uh, Let me take this example itself. Think about it for 5 minutes. If you have any, are you getting any idea how can each element in this, let's call this a right sublist, and this has left sublist, and we have to merge these both lists which are already sorted. The right sublist is sorted, the left sublist is sorted, and we have to merge them in such a way that the list that we are going to get has all the elements in the left sublist and right sublist, and this is also sorted. Think about it for 5 minutes. Actually, there is no only one approach. You can use high, low, high, mid. There is one way that is commonly used in merge and you can also write two different programs, one for dividing and one for merging. And every time after you divide the list completely into single length of a single sublist, you can call the function merge and you can do it in the same way. That is one type, and you can write it in a single program merge sort where it divides and simultaneously merges them. One idea that I have is, let me consider as consider this as the index of the right sublist j, that is represented with j, and the index of left sublist is indicated with I. I'll start the program with I is 0 and j is 0, which indicates the first element in both the lists. And also indicate, I'll also need one more variable k, which represents this the array that we are going to merge, that the result that we are expecting. Because I need to know when to stop. I'll stop when I have when the length of the result array is equal to length of subarray left array and length of right subarray. The sum is equal to the this length. So I'll check the first element of the left subarray and the first element of right subarray. Here 1 is less than 3, so I'll write 1. Since I took one element from the left subarray, I'm going to increase I. Now I will I will become 1. Now I'm going to compare 3 with 5. 3 is less than 5, so I'm going to add 3. Now k is representing third element here. And since I added 1 from the right sublist, I'm going to increment j. J will be 1. Now I'm comparing the second element in the left subarray and second element in the right subarray. 5 and 10. 5 is less than 10, so I'm going to add 5. And since I added 1 from the left subarray, I'm going to increment I. Now it will become 2. So I'm comparing 8 with 10 now. 8 is less than 10, so I'll add 8. And I'm going to increment I. I is 3 now. So that indicates 15. 10 and, I'm comparing 10 and 15. 10 is less than 15, so I'm adding 10 to the result array. And since I added one element from right subarray, I'm going to increment j. So now I'm comparing 15 with 16. 15 is less than 16, so 15 I'll add into the subarray and I'll increment j. Now I'm comparing 16 with 24. 16 is less than 24. It will become 3. I'll increment j. It will become 3. Now I'm comparing 20 with 24. So uh, I'll add 20 is less than 24. I'll add 20 to the subarray. Now all the elements in the right sublist are added. There is no element that I'm going to compare it with 24. But my result array is not yet completed because not all the elements that are in the left subarray are present in right subarray. So I should add 24. Not only 24. So I'll add a 24. But let's assume it's not 24. We have one more element here. Let's assume there is 26 here. So in that case, I should add it here. So what you will understand here is, I have to run the loop till every element in either the left subarray or right subarray should be added into the result array. After it's done, if the left subarray or right subarray all the elements are in the resulted array, I can simply add the remaining elements in the same order because the left subarray is already sorted. So I can simply add them. There may be there may be 27, 28. No matter how many elements that are present here, you can simply add them and you will get an array that is sorted. I think with this algorithm, let's try to convert this into a code. And since we are adding each element and we are comparing, if you observe, we are comparing 1 with 3, we are comparing 5 with 10, we are comparing 8 with 16, we are comparing each element with at least one element in the right subarray. So what will be the time complexity here? We are going to add all the elements in the left subarray. Let's say in the left subarray we have m elements and in the right subarray we have n elements. In the total, uh, the given unsorted list may have n elements. So it will take the time complexity of m plus n, because we want to add each and every element from left subarray and right subarray into our answer, the result. So when we combine this, uh, our time complexity for merge sort will be n log n. Log n, where log n is for dividing and n is for merging each. Uh, this is the last merging, but before this we'll have several mergings. Like 3 and 16 will be merged once, and 3, 16, 10, and 10, 20 will be merged once. So all these mergers will take m plus n time complexity. So to hold together, when we are given unsorted array of length n, the time complexity taken to sort it using merge sort is n log n, where log n is for dividing and n is for merging. With the same algorithm, let's try to write a code. Let's try to convert this. 1 minute. I think you can see my screen now. The collab file. I want to write a program which works for all the arrays, all the lists. I'll name it as merge-sort. I'm going to use a single program. I'm not going to write two different programs, one for dividing and one for sorting. We'll use the same algorithm and we'll try to write it. The parameters will be an array. They'll give us only the array, an unsorted array. We'll assume it as an unsorted array. First, I have to divide it. I have to divide it recursively till I get sublist of size 1. So I have to do this till I'll get the till I get the subarray of length 1. So, and every time, how am I going to divide it? I'm going to divide it using the mid element. I'm going to half the list. If they'll give me a list of 10 elements, I'm going to divide them into 5 elements and 5 elements. So I need to know the mid. So what will be the mid? The mid will be half of the length of array. And we'll use the same names. ls will indicate the left subarray. So I'm going to divide array to till mid. Mid is exclusive here. So I'm going to add it in the right subarray. RS indicates the right subarray. It will start from mid to the end. But is it fine if we do it only once? If you see now, if the array, let's assume the given array is of size 10, and it is the length of array is greater than 1. The mid will be 5. The length of left subarray will be 5 and right subarray will be 5 after this lines. But I don't want a subarray of size 5. I need a subarray of size 1. When the length of subarray is 1, we'll simply uh, go to the next line, because I'm going to call merge sort again. Merge sort again. But I'm going to give the left subarray first. and the right subarray afterwards. In Python, only after executing the only after executing the first line, we'll go to the next line. So this indicates that whatever we did manually, that's not correct. In program, the left subarray will be sorted first, then only it will go to the right subarray because it's not dividing it first. After dividing the left subarray, it will divide the right subarray. It will again backtrack in the similar way how it divided. So the left subarray will be sorted first, and right subarray will be sorted afterwards. No, now this program will end after the length of array is one. Till it is one, we will continuously call merge sort of left subarray and right subarray. So we'll have different elements. Here, I don't want to take a new array and add them. I want to do it in place. I want to sort it in place. We'll take the same parameters that we have discussed, I, j, and k. In the beginning, they will be 0. And till till when should I uh, merge them? Till the length of the array. Here we are while discussing on paper, we told that it should be we will do this till the length of the array will be equal to length of the subarray left subarray plus length of the right subarray. But here we are trying to do it in place, so the length of the array will be same throughout the process. It will not be sorted, but the length of array will be same, so I cannot use it. But I can use I and j. Now I have I, j, and k. So okay, I can simply say that if I is less than length of left subarray, the I should merge it, right? Because if I exceeds length of left subarray, that means all the elements that are in left subarray are in right subarray are in the result array. I think you get it. And even all the elements that are in right subarray should not be in the result. Then if they are in the result, I will stop the process. And now I am going to compare left subarray's ith element with right subarray's jth element. That's what we did. So let's convert it into the left subarray's ith element. I'm checking whether it is less than or greater than the right subarray. Yeah, if it is less than, if left subarray's ith element and right subarray's jth element are same, then I'll simply say that our array, the given array's kth element will be um, left subarray's ith element because that is less. And here we should remember that we have to increment I, and we should also increment j. Sorry, k. We should also increment k. We shouldn't forget it. Otherwise, it will update it in the same place. And else, and I need not check whether the elements are equal, because even though if they are equal, it will come into the else condition, and they will be there will it will be sorted anyway if we have the same elements in the list. Right subbar is jth element, and I have to increment j here because I added one element from right subarray into the array, and I should also increase k because I added k. Now let's think all the elements in left subarray and right subarray are added like this, but there will be some cases where I'll give you an example. Let assume that the left subarray is 1 2 3 4 5, and the right subarray is 6 7 8 9 10. both the lists are sorted. And when we are trying to compare, we'll compare the first element in the left subarray and the first element in the right subarray, that is 1 and 6. 1 is less than 6, so we'll add 1 into the result. 2 is less than 6, so we'll add 2 in the list. 3 is less than 6, so we'll add 3. In the same way, 4 and 5. So all the elements that are in the left subarray are added. Now the I will be length of subarray, and while condition will be false, so will not go into the while condition. But I have 5 more elements that are in the right subarray which have to be added in the result. And I know that the right subarray is already sorted, so I can simply add them in the list. Let it be in the left subarray or right subarray, I should add them in the list. So I'll write a condition where this this should start after completing this while. So I'm please check the indentation also. And if I is less than length of the left subarray, that means all the elements that are in the left subarray are not in the answer. I'm checking that array's kth element should be left subarray's ith element, and I have to increase I, and I also should increase k. And what if there are pending elements in right subarray? Let's check that. While j less than length of right sub right subarray, I need to add them into the array. To right subarray is jth element, and I have to increase j, and now I should increase k. And I think this is fine. Here we can simply write we are either if it is an if or else we are adding it. So let's simply increment it here. Hmm. Yeah, I think till here it is our dividing program, and after dividing we are merging them. We'll also try to see step by step process of this. Let's check whether this program works or not. Let's take an array, a random unsorted array. Let's take 9, 5, 8, 1, 2, 4, 5, 6, 7, 8, and I'm going to call merge. I'm not going to return anything. This function does not return anything. If you give the merge sort an array, it will sort the array. That's it. It is not going to return anything. So I'm just simply calling merge sort on this array, and now if our programs works correctly, our array should be sorted. Let me print it. I'll print the array, and let's try to run it. Yeah, the list is sorted. Now let's talk about the best, worst, and average cases, and let's see how much time does it really take. What is the best time complexity, or what is the best case for this sorting? Any sorting actually. If the list is already sorted, do we need to compare each and every element? We compare the first element with the second element, which will because the list is already sorted. We'll have the first element will be less than second element, so we can simply add 1 and increment I. The second element will be less than third element, so we'll increment I and we'll go to the next. In the same way, we'll do for the right subarray. So the comparisons are less. This will be the best case. But every time We start our merging only by only after dividing them into single length subarrays. So we are not the login is fixed here, and after dividing them into uh, sublist of length one, no matter we don't know whether they are sorted or unsorted, it will take n either way for merging. So it is n log n. That is for the worst case. What will be the average case? The average case will be an unsorted array, random array. So that is what we discussed. Though it will be n log n. But what will be the uh, worst case? The worst case will be the array is sorted in the reverse order. Then we have to check then we have to check the first element with second element. It will be greater than it. So we have to check it with the third element. It will be greater than it. We have to check every element till the last element, which will be less than it. So we have to take the first element and keep it in our result array. So the worst case appears in merge sort when the array is sorted in the reverse order, that is in descending order. But but the time complexity doesn't change. It will be the same and login. Let's I'm going to import time and let's see whether it is taking really the same time for best case, worst case, and average case. Generally, when we talk about best case, it should take less time, right? Because that is the best case. And when we talk about worst case, it should take at least a few more seconds than the worst case. And this time is actually every time it is different for each and every list. So it may vary a little bit, but let's try to see the minor changes. Let's try to change the length of the array also. Then I think we'll get a clear picture. Now I imported the module time, and before merging, starting the merge, I'm going to uh, take the time. I'll call it as in time or start time. I'll say start time is equals to time, and after sorting I'll say end time. End time equals to time, and I'm going to print array, and I'm also going to print end time minus start time. Now let's take the best case where the array is already sorted. Let's take 10 elements starting from 0 to 9. It is taking some time. Let's note it here. Now I'm going to see the average case where the numbers are random. I think I wrote all the elements 4, 5, 6, 7. Yeah. 0. I missed 0. Okay. It's taking more time, right? No, no, no. It is using the logarithmic e to denote time. Let's try to convert it afterwards. It is saying that some number e raised to the power 0 minus 5. Let's see what is e power minus 5. Let's try to see. Now we'll see we saw the best case, average case, and now we'll see the worst case, which is the reverse sorted array. We are getting This is also in e power terms. I'll see. I'll see whether can we convert this into e power terms. So when we convert the given number into e power minus terms, it is this into e power minus 0.5 times, which is similar. But even though I'll keep the same list and I'll try to run the program, every time it will give us a different type. That's because it varies. See, now it changed. Now it is not using e terms. Okay. We saw the program and we saw its time complexity, best, worst, and average cases. Now, let's see whether do we have any other ways to solving merge sort, or till now, if you have any doubts, you can please write in the chat box or you can unmute and ask me. Can someone say where do we use sorting other than while binary search? Do we find where is it useful sorting a given list? Actually, generally we learn sorting on list which has numbers, but we can sort even uh, a list with strings. We can if we have words starting with A and words starting with B, words starting with C in a random order. We can sort it. Actually, we can use the inbuilt sort method, which will give us the alphabetical order of the array. It will also use the same comparison. We will take the ASCII values of each alphabet. It will compare it with the same strategy, and if it is less, the ASCII value of A is less than B, so it will say add A in the first and B in the second, the same way. And do we have any real world applications of merge sort? Let's check. Generally, whenever we use divide and conquer, we'll always use recursion because divide and conquer nothing but we are dividing the problem into simple and solvable problems, which is the basic motto of recursion. Recursion also happens in the same way. We are going to convert a big problem into a smaller problem, and we are going to apply our algorithm there. In binary search, we divided the list into half, and we checked whether the target element will be left or right. We converted a bigger problem into a smaller problem. In merge sort, we took an array and we have divided each array into a sub list. So here we are making a bigger problem into a smaller problem. Then we are sorting the left sub array and right sub array. That is our algorithm, or we are using some our solution. And after that, we are going to merge them. So wherever we use in quicksort or merge sort, anywhere we use divide and conquer, Mostly we use recursion there because we are converting a bigger problem into smaller problems and then we are applying our solution. If you know about databases, in our databases, sorting is very important because they need to. Let's take an example of a bank. So every card has a number, uh, unique ID, and if it is not sorted or if it is not, if we don't know when it is sorted in the date format. So a person who created his account today will be having a account number, less account number than person who takes a account tomorrow. So it will be very easy for them to give an update to the client or uh, send them messages, so like that. So if you have any doubts, you can ask me now. Okay, I want to show you one thing. If we Let's see the step-by-step procedure of this. I'm going to use Python tutor and let's see how the subarray is uh, dividing and sorting it. First dividing and then merging it. I think you can see my screen. I'm giving the array, the similar array. I copy paste the same code. Now I'm going to start it. This is the given array, and I'm calling the merge sort function. The length of array is greater than one, so I'm calculating the mid and taking two subarrays, left subarray and right subarray, and I'm applying merge sort on left subarray. So this will happen till the subarray becomes one. That's what I was talking about. When all the left subarray elements are uh, converted into single elements, then we'll go to right subarray. You can see it here, right subarray, and we'll have the right subarray. And after dividing them into length of single length sublist, we're going to merge them. So I took I, J, K as 0, and while I less than K, I'm checking the left subarray as first element and right subarray as first element, and I'm comparing them, and I'm going to replace. Now you keep an eye on our array here. After each and every comparison, you see the left subarray will be sorted. So now we have 987654321, but whenever we simply do it, now 6 and 7 will be sorted. Yeah, 8 and 9 is already sorted. Now we are going to merge 6, 7, one sublist, 8, 9, another sublist. It will compare and it will happen. Uh, I want to show you one thing where the left subarray and right subarray will be sorted, and then it wants to add them. Here you can see the right subarray is 1, 2, 3, 4, 5, and the left subarray is 6, 7, 8, 9, and 10. We'll have 10 there. 6, 7, 8, 9. So the left subarray and right subarray are sorted, and after then only we are going to compare it and add it. So till the last step, we will not get an array that is sorted at least 2, 3 elements. In other, I'm talking about this point because in other sorting algorithms, after n steps, we'll have this array sorted for at least n elements. There are some sorts like that. But in this, we have to complete the process. Then only we have a completely sorted list. Till then, we cannot guarantee that the list will be sorted at least for n elements. So now it will simply add them and the list will be sorted. Okay, you can message me if you have any doubts. I'll leave my. Yeah, bye guys. If you have any doubt, you can unmute and or you can message. You can mail me or you can type in the chat box. And is it okay if I feel while you are learning the algorithm and coding the logic, personally I feel Python is best. But if you want the same code in Java, I can share you the file. Uh, I'll tell our mentors to send it to you. Yeah, I have sent the .java file. That is the same algorithm in Java. You can mail me if you have any. Okay, guys. Then thank you. We'll meet again in another.